Hey everybody, it's Jacob with Wilman Air, and today we're going to go over your capacitor, what it does, and how to replace it. To check your capacitor, you're going to need some tools. First, we'll want to get a good multimeter that is working, a set of wire strippers or even pliers will work, and this is a multi-tool which has multiple screwdrivers in it. It can handle Phillips head, flat head, 1/4 inch hex head, and 5/16 hex head. Okay. First thing we're going to want to do is ensure safety. So let's make sure our breakers are off. AC and heat, both off. Yeah. Next, we're going to proceed to our outdoor unit. At our outdoor unit, we're going to verify that the voltage is no longer present, and we're also going to start looking at all the different components in there. Once you locate your outdoor unit, we'll need to walk up to it and start by opening this service panel on the corner. This is where that multi-tool will come into play. So I like these because it's a nice compact tool and has about 6 in 1. Right now we'll need the 5/16 attachment to undo this panel. Be sure to set your screws someplace where you'll find them and not knock them out of the way. Okay, now that we have the outdoor unit open, we're going to go ahead and grab our multimeter and make sure there is no high voltage coming into this unit. That'll make it safe so we can work on it. On your multimeter, you want to turn it to VAC. That's voltage alternating current. VDC is for voltage direct current. Difference between AC and DC. We want AC. So we're going to turn it on there. Then we're going to test where our wires actually come into, which is right at the bottom of this contactor up here. We're going to put one lead on one leg, one lead on the other, and we should read about 0, which we are, 0.053 or so. So we're good. We're free and clear. Next, what we're going to want to do is designate what is our capacitor. Well, here's your capacitor right here. So what I'm going to do, I'm going to hold this like so you can see, okay? All your motors inside your AC unit are 3-phase motors, and we only have single-phase power. So we need to find a way to provide 3-phase power. That's what this capacitor does. It basically builds up a charge on one side while the charge is applied to the other side and then releases it. So it doesn't generate power, it simply stores up an extra charge opposite of one side of the power coming in and then releases it. So it's all about timing and providing that voltage. You need the correct capacitor because if you don't have the correct size capacitor, or it is out of its tolerance, which we'll go over that shortly, your motors will end up drawing too much amperage. And when your motors draw extra amperage, the windings inside of them tend to overheat, and now you have bad motors, which is much more expensive than your capacitor. So let's begin by taking the wires off the top of the capacitor and undoing our little bracket over here so we can take the capacitor out and go work on it. I like to use pliers. So these are wire strippers, but they actually have a little nub up here you can grab stuff with without cutting them. And I just grab the spades connectors and then simply pry up on them. You can see they come right off. If you do it right, you're not damaging the spade connector or the wire. Pulling up on them can rip the wire out of the spade connector, causing a loose connection. So you want to be careful not to do that. Okay, all my wires are detached. Gonna re-grab my little 8-in-1 screwdriver here. That is another 5/16. So we're gonna go ahead and undo that. By the way, magnetic tips are a necessity. Don't know what I'd do if I didn't have magnetic tips. I'd be losing lots of screws. That's what I'd be doing. Okay, So as we look at this capacitor, there's a couple things to notice. Rust on the top, not a big deal, right? We're looking at the internal components inside for failure. We're not looking to the outside condition of it. However, if you do ever notice that your capacitor is bubbled or rounded on top, which this clearly is not, that is a clear sign that the capacitor has failed, okay? And you can verify that with measurements, which we will go over, but first we want to know what we're measuring. This is your microfarad rating. So this is a dual run capacitor. Power comes in, and then it feeds three-phase power to the fan motor and your compressor. So you have two motors, the fan that spins on top and the compressor that pumps the refrigerant. So therefore we have 2 microfarad ratings. 70, always the larger one, is going to be for your compressor. So that would be 70 microfarads. And then it's 7.5 going to the fan. Your smaller one is always the fan. If you actually look on top, it's kind of hard to see, but the top of this capacitor is actually labeled. The middle, where power comes in, is labeled common. The one that feeds your compressor is labeled HERM, H-E-R-M. That's short for hermetic compressor. And this one is easily labeled fan, F-A-N. So very important to know what terminals you're hooking up to, because if you cross them, you'll feed 7.5 microfarads to your compressor and 70 microfarads to your fan. That's going to cause a lot of damage in the long run and not be good for anybody. So as we're looking here, we see the microfarads that we want to see when we test it, and there is also a small tolerance level there. I'm not sure if you can see it on this one, but it says plus 10%, minus 5%. So on the 70 side, right, we can read 10% over 70, so 77 is right there on the line of tolerance. If it's over 77, we need to replace this capacitor. And then it says minus 5%. So if 7 is 10%, then 3.5 is 5%. So if we get down to 66.5 microfarads, we are right there on the cusp of needing to replace this. Anything below 66.5 is beyond 5% lower than what the capacitor is rated at, which is 70. So it needs to be replaced. If we're within that 66.5 and that 77, the capacitor is good to go and you do not need to replace it. You probably have a problem somewhere else. Okay. So showing you all of this, you really don't need to undo your capacitor completely when you are checking it. I just wanted to be able to point out the labels. So important things you want to know are labels on your terminals, the actual ratings of microfarads for your 2 motors, and the tolerance level. Okay. So I'm going to go ahead and just put this right back on there, and I'm going to test this in place. And let's just say you did find it was bad. This would be how you replaced it. Pretty easy. Take the old one off, put the new one on. But you want to be sure you need to replace it, right? Let's not waste money. Okay. That's it. There we go. Okay. So I really hope you guys can see this here. I'm just going to bring this up here and I'll show you. So what we're going to do now is take our multimeter and we're going to move it to MFD, which is short for microfarads. And this is how we test capacitance. And then very simple. When you test for capacitance, you are testing between the common and the terminal you want to test. So if I want to test capacitance for the compressor, excuse me, you would test between common, which is right in the middle of that capacitor in the top, and hermetic, HERM, which is your compressor terminal. So let's go ahead and do that, and we should see 70. I'm going to see if I can hold this and do this. And there it is. If everyone can see that, it says 68.5. So 68.5 microfarads is well within our 66.5 to 77. So this is good on the compressor side. Now they are 2 totally separate circuits between the compressor and the fan inside this capacitor. So we need to test both. So again, doesn't matter what lead I use. I'm going to go between the common and the fan, and we're looking for 7.5 plus or minus 10%, and we have 7.79. Okay, so 7.79, we are good to go there too. So this is a good capacitor. Now, these capacitors right here are AMRAD. It is probably the best brand out there for capacitors. They come with a 5-year part warranty. We put a 1-year labor warranty on them as well. You can buy them. Link in the comments on where to get that and where to get a multimeter if you do not have one that tests capacitance. But we don't recommend any other capacitors. The majority of them will fail. These are slightly more expensive, but with a 5-year part warranty, that's standing behind your product. All other capacitors really only come with a 1-year part warranty. So AMRAD we definitely recommend, and that's about it as far as testing the capacitor. Now we have to hook it back up. So what we're gonna do is you're gonna have 2 leads on your common. One is going to be coming off this contactor right here, and that is going to feed power into it. So I'll go ahead, hook that right back on there, and that's right in the common area. Let me move this. Okay, that's common. Now what you actually have is, don't get confused by this, but this wire right here actually goes to the fan, but it's not the one that needs the capacitance. So it's actually just going to take power right off of the common as well. And you'll see that a lot. You'll have 2 coming off the common terminal of your capacitor a lot of times. It could either be attached right here or back here. Either way, it's just taking the same power as wherever that common's coming from. So it's just piggybacking off of that terminal. This is our fan wire, which happens to be brown. It's normally brown on a lot of systems, including train and carrier. And orange is our compressor capacitance wire. That's on train. On carriers, you're gonna see it be blue. Okay, and that's it. Once you're all hooked back up, you need to go reapply power, and hopefully your system starts. Thanks for joining me today. If you have any questions, leave them in the comments. Love to hear from you guys. Hopefully this will help you all out. Again, there are links in the description where you can get your own capacitors and your own tools so you can do this at home. Have a great day. God bless.